This is the first problem in the challenge your understanding section. So let us see the problem. A wedge of mass capital M can slide on two parallel rails A and B, inclined at an angle theta to the horizontal. In the middle of the rails and parallel to them runs a frictionless rod C that wears a light ring capital D. The rod does not touch the wedge. A light inextensible cord attached with the ring runs through a hole in the wedge without touching it, then runs around an ideal pulley and the top of the wedge, and finally attached to a block of mass small m that can slide along the vertical face of the wedge without friction, as shown in the figure. Coefficient of friction between the wedge and the rails is mu. The coefficient of friction between the wedge and the rails is mu. Initially the system held motionless and then released. Find the acceleration of the block. Acceleration due to gravity is small g. So now let us proceed to the problem. So this is the diagram for the given problem. If you see, this is the block of mass small m and this is the wedge of mass capital M. You can see the hole also, and this is the way the entire arrangement is set up. And now we are going to solve this problem, students. But first of all, we have to consider the case when the system is held motionless. Okay. So now let us see the free body diagram. So whenever we are going to do this kind of problems, first of all we have to draw a proper free body diagram. Without proper free body diagram, we cannot solve this kind of problems. Now let us see the free body diagram. So this is the free body diagram when the system is at rest. So you can clearly notice the forces that are acting on this system. So I will once explain. First of all, I have resolved this mass capital M, and the weight due to this mass capital M, that is mg, is acting vertically downwards, and it is resolved into two components, that is mg cos theta and mg sin theta. Mg sin theta is a component which is acting along the incline and it is downwards, and mg cos theta is a component which is acting normal to the incline, as shown in the figure. And see here, so tension directions also clearly indicated in the free body diagram, and here the weight of the small m is acting vertically downwards as shown in the diagram, and this is the normal reaction capital N experienced by the wedge. So these are the forces so that are acting on this system. Of course some other forces also there, but I did not mention all the forces. I mentioned only the forces that are very useful in solving this problem. Okay. So now let us see the free body diagram of wedge. Now let us see the free body diagram of only wedge. I am not taking the block in this situation. So now see here. So this is the free body diagram of only wedge. So these are the forces. So now see here, this is the point where the pulley is attached to the wedge, and the tension is acting downward direction. Again tension is divided into two components, t cos theta and t sin theta at this point, and another tension is acting on the other side of the pulley, and it is acting opposite to the normal. And see here, again I have shown all the forces acting on the wedge of mass capital M. Now let us proceed to the solution. So first of all we have to write the equations of motion when the system is at rest. So now let us proceed for the equations of motion. So if you take this situation, the block is at rest and the wedge is also at rest. The entire system is at rest. So if the entire system is at rest, then all the forces acting on this wedge must be balanced forces. All the forces must be balanced forces. So we can balance all the forces along vertical and horizontal directions. Suppose if I consider the horizontal direction, that means along the incline, what are the forces? What are the downward forces? Mg cos theta, mg sin theta, t sin theta are the downward forces, and so the friction force is the only force which is acting in upward direction. So I can balance these forces because the system is at rest, it is not moving. That means the downward forces summation must be equal to the upward force. So what I can write, t sin theta plus mg sin theta is equal to friction force. that is mu into n. So this is the equation number 1. Now see next one. We are going to concentrate on the vertical forces. How many forces that are acting normal to the incline? See, mg cos theta is the force which is acting down, and t cos theta is the another force which is acting down, and t is also another force which is supporting this t cos theta also. So 3 forces are finally acting perpendicular to the incline in downward direction. See here. And the normal force is the only force which is acting in upward direction in this manner. And what we can do, we can simply equate those forces in this way. So t plus t cos theta plus mg cos theta is equal to normal force. So this is the equation 2 we are getting. So we have completed the one segment of this problem. Now let us proceed to the next segment. We have to solve this. We have to simplify in proper manner. Okay. And you see here the system is not moving. The system is not moving means, if you talk about the block of mass small m, the small m is also at rest. So we have to notice one important point. When the system is at rest, when system is at rest, so tension is also equal to small m into g, because it is not moving. The block small m does not move relative to capital M. So this is the situation. So we have this equation 3 also. So now what we have to do? We have to solve these 3 equations, and we have to obtain the coefficient of friction in this situation. Now let us see. We are just writing the second equation in the first equation. So now I am writing, just see, t sin theta plus capital Mg sin theta is equal to mu into normal reaction. Normal reaction is t plus t cos theta plus mg cos theta. So we got it. In the place of t, I can write small m into g sin theta plus capital Mg sin theta is equal to mu into small m into g plus small m into g cos theta plus capital M into g cos theta. So you can cancel this g throughout the equation. You can cancel the g throughout the equation, and simply you can write small m into sin theta plus capital M into sin theta is equal to. So here we can simplify. We have to cancel this g throughout this, and what we are writing, mu into small m plus mu into small m cos theta plus mu into capital M cos theta. So this is the thing that we got finally, and here we can take out these cos thetas one side and mu into m one side. Mu into m, you can take the cos theta common, mu cos theta common. So what we are getting, capital M plus small m. And here, so we can take out this sin theta and small m plus capital M into sin theta. So this is the thing that we got, and finally what is the mu value? Mu value is equal to small m plus capital M into sin theta divided by, so we have already did separated, and you are getting small m plus capital M plus small m into cos theta. So this is the coefficient of friction when the system is at rest. When the system is at rest means the system is not moving. System is not moving and it is at rest. Okay. So this is the coefficient of friction in this situation. But initially it was at rest. But what happens when it released? It's moving. So here we have to define some conditions. When the friction coefficient is greater than the value that we have obtained here, that means the greater than small m into capital M sin theta divided by small m plus capital M plus small m into cos theta, then system does not move. Then system will be at rest. That means acceleration of block will be 0. Acceleration of block will be 0. So we can directly say when mu is greater than this value, definitely acceleration of block will be 0, because the system, the entire system will be at rest. So the small m will also does not move. Now let us move to the next case. What will happen if the coefficient of friction is less than small m plus capital M into sin theta divided by small m plus capital M plus small m into cos theta? What will happen in this situation? Then system will move and acceleration of block is not 0. So now we have to concentrate on this case. We have to obtain the acceleration of the block. How to obtain the acceleration of the block? So now let us see the free body diagrams related to that situation. How to obtain the acceleration of the block. So now let us see the free body diagrams in this case, and I'll explain this once by seeing the free body diagram. See, I have already plotted the free body diagrams, so you will get one clarity. This is the free body diagram of wedge. This is the free body diagram of wedge. Now we are considering the motion of the system. We are considering the motion of the system. The system is not at rest. The system is not at rest. Definitely it is moving. So if you are talking about the wedge will definitely move in downward direction, in this direction with some acceleration 8. So we have to notice that point, and these are all the forces that are acting on the wedge at that instant. I have represented them in the free body diagram with a full clarity. Now let us see how to write the equations of motion for the wedge. So first of all, we have to write the proper equations of motion for the wedge, and after that we have to concentrate on the block. Now see students, here I will explain once again by seeing the diagram. So there is a contact between the small m and capital M. Small m is the block and capital M is the wedge. So at this point of contact, so both wedge and the block will experience a contact force. So I have shown that contact force here. So this is the contact force N dash that is acting on the wedge. You can clearly see I have represented that contact force with yellow color arrow that is acting on the wedge, and I have resolved that contact force N dash like N dash cos theta and N dash sin theta, and weight is also already resolved. And if you talk about the tension, the pulley is attached to the wedge, so automatically the tension forces are acting in this way, T cos theta and T sin theta, and on the other side we are having T also. So see, these are the forces acting on the wedge at this instant. Now let us see how to write the equations for this. So if you are talking about the equations, first of all we have to write the equations that are very useful. And see, this acceleration is acting in this downward direction, and see, first of all we have to point out the forces which are directed in the acceleration. Forces which are in the acceleration direction. So mg sin theta is the one force, and T sin theta is the one force which is in the direction of acceleration. Okay, and friction force is opposite to the direction of acceleration. You can clearly notice, and N dash cos theta is also opposite to the direction of acceleration. So first of all we have to write only the forces which are in the direction of acceleration, and then we have to subtract these forces which are in opposite direction to the acceleration, and then we can write net force, and that will equal to ma. So now I am going to write that. So if you see the forces which are in the direction of acceleration, what is the summation of that one? Capital mg sin theta plus this is T sin theta, and one part is over. Next, forces which are opposite to the direction of acceleration. We have to subtract them, and this is the friction force and n dash cos theta. Now see, and I am writing that the friction force F and n dash cos theta, that is equal to mass multiplied by acceleration, capital M into A. So this is the equation that we got. Let us say this is equation number 4. Okay, and let us proceed for another equation. So because we are having the vertical forces that are acting on the wedge, which are normal to the incline. See here, n dash sin theta and mg cos theta and t and t cos theta are the forces which are acting in downward direction. Okay, so here there is another force also, that is tension, sorry, not tension, yeah, the tension only, the tension which is acting in this direction, but in this direction we are having the normal force n also. So now we have to write another equation for this wedge. Now see that equation. So but there is no acceleration normal to the incline. So what we can do, we can equate all the forces and we can balance them. And see, these downward forces must be equal to upward force. What are the downward forces? T plus t cos theta plus capital mg cos theta plus n dash sin theta n dash sin theta. So all these are the downward forces. The only upward force is normal reaction. So that must be equal to n. So we got it. So this is the way of writing these equations, and let us say this is equation number 5. We wrote the two equations. Next, what we have to do? So what we have to do? So we have to observe carefully what we are doing here, and yeah. Now let us come here. Let us come to the FBD of block. Now we are considering the FBD of block when the system is moving. So here you can definitely see that there is a motion of small m relative to the ground, and I have resolved the acceleration also. You can clearly see, so the acceleration is resolved, and this is the a cos theta, which is acting in negative x direction, and a sin theta is acting in downward direction. So this is the acceleration with which the block small m will move in downward direction, and this is the acceleration with which the block small m will move in negative x direction. And here the force is acting n dash on the block small m in negative x direction. So see, this is the positive x direction and this is the negative x direction. So now if you observe that situation, n dash can be written like this: n dash is equal to mass multiplied by acceleration in the direction is a cos theta. A cos theta is acceleration in the direction. So we have completed. This is the equation number 6. Yes, equation number 6. So we got all the equations that are very important in our discussion now. We got all the equations that are very important in our discussion, and now we have to simplify these equations. Not only writing, we have to simplify them in a proper manner. So if you are not simplifying these equations in a proper manner, again you have to face the difficulty in calculating the acceleration of the block small m. Okay, now we are going to write the another equation also for small m, and mg is acting downward direction and the tension is acting upward direction, and you can simply write mg minus t is equal to ma sin theta. Okay, and the tension can be written as mg minus ma sin theta. So this is the equation 7 we are getting. So we got the tension also now. Now what we have to do? We have to solve equation 4, equation 5, equation 6, equation 7. So these 7 equations. So it will be little bit tedious job, but we have to solve. We have to solve to get the answer for this problem, because it is a challenging problem. So here in the place of n dash, directly you can write this ma cos theta. Okay, no issue. So now I am replacing that. for solving equation 4 and 5 and 6 and 7 for acceleration. Now see students, from here onwards it is purely mathematics, nothing, only substitution and solving, purely mathematics. Now see, we have to write the n dash in the fifth equation and fourth equation. First of all, I am going to complete that process. So now let us take the fourth equation first. Let us take the fourth equation first, and I am using that equation here. So this is the fourth equation that I got, and in the place of n dash, what I have to write? I have to write ma cos theta. So mg sin theta plus t sin theta minus the friction minus what is n dash? Ma cos theta. So small m into a into cos square theta is equal to capital M into small a. One portion is over. I have taken the fourth equation and I have used it here. I have used 6 in 4. I have used 6 equation number 6 in equation number 4. Okay. Now, what is the friction? Friction is maximum value at mu into n, you can write. So capital M into G into sin theta plus T sin theta minus friction can be written as mu into n minus ma cos squared theta is equal to capital M into small a. But what is this n? I want this n. How to calculate this n? Yeah, in order to do that, we are already having this n value here. Now what we have to do? We have to change the n. Now I am writing that n value here. Just see, we have to write this entire equation here. So again it becomes a very lengthy. Capital M into G into sin theta plus T sin theta minus mu into, in the place of n, I have to write this very big equation. I can't even remember this equation also, but we have to copy it, paste it. So in the place of n, I am pasting that equation. I have pasted it, and see, and this is yes, this is n dash. Okay, and we are having a big bracket here. So we have to note that point. This is n dash. Okay, next, minus ma cos square theta is equal to capital M into a. Okay, now see what we have to do. Now we have to simplify this in a proper manner. Again, if you are doing any wrong in simplification, again definitely this entire answer will becomes wrong. So be careful in simplification. So capital M into G into sin theta plus T sin theta minus mu into T minus mu into T cos theta minus mu into capital M into G into cos theta minus mu into n dash into sin theta. So just wait students, I will enlarge this, n dash into sin theta minus m into a into cos square theta is equal to capital M into a. Okay, but here already we know what is this n dash. N dash is again ma cos theta. We can write here. Okay, don't forget anything. So now I am using, again I am using equation 6 and equation 7. Use 6 and 7 on this equation. See what we will get if I use capital mg sine theta plus, in the place of tension I have to use this. So what is this? Mg minus ma sine theta. Mg minus ma sine theta into sine theta minus mu into mg minus ma sine theta. Okay, minus mu into mg minus ma sine theta into cos theta, into cos theta. Don't forget anything, very big equation we are getting. Okay, and minus mu into capital M into G into cos theta. Okay, minus, instead of n dash, what we have to write? ma cos theta. So minus mu into minus mu into ma sine theta cos theta. Okay, minus, again becomes tedious, we have to decrease this, minus ma cos square theta is equal to capital M into A. We have to simplify this and we have to cancel the terms that are going to get cancelled in a beautiful manner. See here, so capital M into G into sine theta. Now multiply this, small m into G into sine theta, and here minus m into A into sine square theta. Okay, and let us multiply this one also, minus mu into small mg minus of minus becomes plus, mu into ma into sine theta, minus of minus it becomes minus mu mg, minus of minus it will becomes plus. So here we have to observe this, mu mg and cos theta is also there, we have to multiply, I forgot. So you need lot of IQ to solve this problem, lot of IQ and lot of memory power also required, and minus of minus plus, and mu ma sine theta cos theta. Now see this one, and here we need simplification, minus mu into capital mg into cos theta minus mu into ma sine theta cos theta minus small m into A into cos square theta is equal to capital M into A. This is the thing that we are getting, and now let us see what are the terms that are going to get cancelled out here. So if you observe carefully, this plus small ma sine theta cos theta minus small ma sine theta cos theta will get cancelled out, and see another terms that are going to get cancelled out, and see what are the terms that are going to get cancelled. We have to cancel them carefully. So if you are doing any mistake, again it will becomes entirely wrong. Okay, is there any terms that we left? Yes, we have left one term, because these two terms, ma sine square theta, ma cos square theta, will becomes ma only. Okay, will becomes ma. Now see, and I am just rearranging. I can take sine theta common from this, and I can write capital M plus small m into G sine theta here, and this one and this one will becomes minus ma, and this mu mg is left, so that minus mu mg, and so here is there anything going to get cancelled, and nothing is left. So simply mu into ma into sine theta I am writing as it is, but here I can combine this two, that I can write minus, so I can take mu g cos theta common, and I can write capital M plus small m is equal to capital M into A. So that is the thing that I left. Now see what we are getting. We can merge these two again, and you can take this common, and capital M plus small m, and I am taking common, into G also I am taking, and we are getting sine theta minus mu cos theta. Okay, And these are the terms that I can send this side. I can leave this minus mu mg this side only, and I can send these two terms this side. It will becomes capital M into A, and becomes plus small m into A minus mu into small m into A sine theta. Okay, so that is the thing that I left here. And I want acceleration, so I can take this acceleration common, and I can simply write capital M plus small m minus mu m sine theta. Okay, and you can also take g common from this, and what we are getting is capital M plus small m into sine theta minus mu cos theta minus mu into m. So this is the acceleration we are getting finally. So small g into capital M plus small m into sine theta minus mu cos theta minus mu into m divided by capital M plus small m minus mu into m into sine theta. So we got acceleration of the block small m when the system is moving. So you can simply write the acceleration in this manner. Acceleration can be written as g into capital M plus small m into sine theta minus mu cos theta minus mu into m divided by capital M plus small m into mu into m sine theta when this is valid. This is valid when, see, we have already noted when we have derived it. You can clearly notice that point. Yes, mu must be less than this one. Mu must be less than this one. I can paste it here. So even it's very difficult to paste. Yes. Yeah. Yes, this is the situation. When mu is less than this one, then this is the answer. When mu is greater than this one, if mu is greater than capital M plus small m into sine theta divided by small m plus capital M into small m cos theta, then acceleration will be 0. Okay, so this is the final answer for the problem. Okay, just see, I am going to show you the total screen. Yeah, this is the final answer for the problem. Okay, so this answer is very, very difficult problem solved. Okay, bye students.